Today we're talking about experimental design, and so just planning a statistical study, the first thing you'd want to do is identify your individuals and your variable, who you want to study and what you want to study. Decide if you can study all of the individuals, the entire population, or if you'll need to use a sampling method. You'll want to plan how you're going to collect your data. You do need to get permission. You have to use ethics. You have to try to protect confidentiality and privacy. You'll collect the data, and then after that, you will describe the data, and you'll use inferential statistics to, like it sounds like, make inferences about how that applies to the whole population or what to do as a result. You do need to note any concerns or recommendations about your data. When I did my master's degree, I did it on test anxiety in the classroom. So what I did is I read a relaxation exercise to my students before every test and quiz. And I just tried to give them a survey to see did it affect how they felt before they took a quiz, and I also looked at their test scores as a variable to see if those improved. But one of the concerns that I wrote up in my paper was I noticed that as a teacher I was less stressed out when I read the relaxation exercise. So that could have been what they would call a lurking variable. We'll talk about that later. But some concerns would be that, well, maybe it was my attitude that made the difference, not technically the treatment that I thought. When we talk about ways to collect data, one way is the census. And the census is when you attempt to literally check on everybody in the population. So the census is meant to use everyone in the population, where a sample is you're admitting that you can't find everybody, so you're going to choose some sort of sampling technique. Sometimes neither of those would be appropriate. A simulation might be used when something is maybe too dangerous or isn't possible to test on an actual population. Here's a simulation that scientists might use to tell about the spread of a virus, whether you have people who are staying home or whether you have people who are out and about. You wouldn't want to just send diseased people out into the population and see how it goes. So maybe you would use a computer simulation to see how it goes. An observational study, just how it sounds, you're not actually doing anything to the population or to your sample. You're just observing how they react to something that's already in their environment. Where an experiment, you would be applying a treatment, and we're going to talk a little more about that. Let's say you were trying to test out a new drug or something. So you'd have this group of sick people, and a control group is where, so you're going to give this new drug to part of the population. They get the new drug. But then this other part of the population doesn't. They get no treatment. And the reason you'd want to do that is because you want to compare the results for the people, whether they were treated or whether they weren't treated, to see if we had a better outcome for the people who took the drug or a worse outcome maybe. There's always the chance that the people who are actually taking a pill will claim they feel better just because they know that they're getting some sort of treatment. So a way to prevent that is to use a placebo. It's called the placebo effect, when you take a pill and you just kind of feel better because you feel like you're being treated. So in a placebo group, still we're using the actual drug on part of the population, but then the other half of the population, we're going to give them a pill that does nothing. That's called a placebo. So sometimes they'll call that a sugar pill. Like, here, swallow this Skittle, see if you feel better. And the idea is that everybody thinks they're getting the new drug or thinks they might be getting the new drug. So that sort of mental factor wouldn't play in. So you can, maybe probably more reliably tell whether the drug was actually having the effect or if it was just people's minds playing tricks on them. A double-blind study, I'll explain who the blind people are. So again, one group gets the drug, One group gets the placebo, which is like the sugar pill or the fake pill with no active ingredient in it. A double-blind study means that not only are the participants blind, they don't know which drug they're getting, if they're getting the real thing or the fake, but also let's say the doctor or the researcher doesn't know until the very end of the study which people got which pill. And that just helps that maybe, let's say you're a doctor and you know that these people are getting that drug and you really want the drug to work. Maybe you would treat them differently than these people who you're trying not to give them a treatment. So maybe you would say, I don't know, you could probably mislead or skew the results just by your own biases as a researcher. So in a double-blind study, the researcher nor the participants neither knows which one is the placebo group. Of course, at the end, when you collect all your data, you'd have to have some way to code it so that you would know which group had the actual treatment. Your goal here is to prevent as many lurking and confounding variables as possible. Like I said, a lurking variable is something that maybe played into your results that you weren't even aware of. Like when I talked about my stress level, maybe that could be the doctor's stress level in a drug trial. That would be a variable that I maybe wasn't studying, but could have had an effect on the outcome. Confounding variables are when variables do interact with each other in ways that you weren't really studying. In my test anxiety experiment, I found that there were some levels of math classes that had better results. So maybe it was grade level, or it could have been gender that had better results. So confounding variables are just variables that are interacting with each other in your study that weren't necessarily meant to be part of like the treatment or the outcome. As far as the design for your study, this is sort of sounds like the way that we do sampling techniques too, but it's probably a smart way to do this. Let's say you had all these sick people. It says patients with chest pain here. And we put half of them into group 1 and half of them into group 2, and we apply a treatment to one and we don't apply a treatment to the other, and then we compare how they feel. That's a completely randomized experiment. That's exactly what I was talking about before. This one's a little different, a randomized block experiment. So first, if we took the patients and we split them into men and women, so that almost feels sort of like stratified or cluster or something. So it's more stratified. Now the men we're going to split into two groups, one who gets the treatment and one who doesn't. Females splitting into groups, one who gets the treatment and one who doesn't. And then we can compare, maybe it works for men and it doesn't work for women or vice versa. So a block experiment is where you deliberately study maybe two separate groups of people, or even more. Replication is really important. Just because you perform a study once doesn't mean that that's the result forever. So replication, every good study is able to be replicated, to do it again and again. And if other scientists are able to run the same experiment on different groups of people and they get the same result as you, that just makes the study even stronger. They know that that data is more reliable then because it's able to be replicated. We all know that sampling error can cause skewed results sometimes. So if you only do one sample and you get a result, that could have some sampling error. But if you do multiple examples, just probability-wise, you're likely to really see how that treatment is working. Quality survey design, I think sometimes this is sort of common sense, but you don't want to make any leading questions. You don't want to make it so that people feel not free to answer the way they should, not answer truthfully. So a quality survey design, and also making sure that what you're asking is very clear to the person responding. If you just say, how do you feel? That might not be as clear as, how does your chest pain feel? I just wanted to put a word to something we've been talking about. A Likert scale is one of those ordinal type scales where you rate yourself on a scale from strongly agree to strongly disagree. So Likert scale is what I used in my study. I asked my students to respond to how anxious they felt right before the test. And any survey you give, you should think about these things that might affect your result. Non-response just means that your participant wouldn't answer the question or maybe didn't even respond to the survey. Voluntary response means that only people who maybe feel strongly or one type of person is going to respond, where people who are too busy to respond will not. So that could involve some confounding variables there. Truthfulness and faulty recall. If somebody asked you how much sleep you normally get, well, you might fudge that number a little bit, or maybe you would accidentally say, oh, I think I get 7 hours of sleep a night on average, and maybe that's just not true. So you have to think about that. Maybe the respondents are trying to answer untruthfully, or maybe they just don't remember correctly. Hidden bias might be hidden in the question or the way that you ask the question. Vague wording is just when you're not specific enough. If the respondent doesn't know exactly what you're asking for, their result might not give you what you were looking for. Interviewer influence. Sometimes you just want to make the person happy that's doing the survey. Sometimes I do this when I rate my, I don't know, like I just got a survey from my doctor. How did your doctor do? Well, I'm pretty sure my doctor's going to see that, and I like my doctor, so I probably want to give her better scores. So interviewer influence, that's a tricky one. You want to know that your results will be completely anonymous is probably the best way to avoid that. And I feel like you're a smart people. I think that if you were designing a study, you would probably avoid some of these pitfalls. You would think about all these things. But really what I want you to get out of this class is that when you hear about a study on the news or something, that you're the one asking all these questions. I want you to be careful about what you believe when the details aren't known. And if you're reading like an actual good study, the researcher reveals these details. Like I said, you're supposed to comment on all of the pitfalls, things that might have skewed the results. One example I've seen in the news lately, and it's hotly contested, is how the West Fargo schools haven't been requiring masks, where the Fargo public schools have. And so then they check their case numbers. And so the questions that people who have a good background in this might ask is, well, what's the same? What's the control? Is everybody in both districts getting tested at the same rate? Or things like that. So, or is everyone vaccinated at the same rate in both districts? So I just want to help you become critical when you hear these studies, because every other night on the news I'm hearing that either caffeine is going to help my health or it's going to kill me, or chocolate is good for me or chocolate is terrible for me. So again, that comes with those replication of studies too. I would want to know that a study has been done multiple times on different groups of people and the same results are coming out before I'm going to believe that.